This is the first video for elementary statistics at Lawrence University. In this video, we will talk about how to visualize data using bar graphs, histograms, box plots, and scatter plots. After watching this video, you should be able to distinguish between categorical and quantitative variables, interpret results displayed in bar graphs, histograms, box plots, and scatter plots, and describe the center, shape, variability, and outliers in a distribution. We will work with a data set that contains information on 272 movies that were released in theaters during the year 2018. Data were obtained from the popular Internet Movie Database website, imdb.com. For each movie, we have information on its IMDb score, a score between 1 and 10 based on votes from fans on the website, its rating given by the MPAA, Motion Picture Association of America. Ratings include PG, PG-13, R, or not rated. The genre of the movie, was it an action movie, a comedy, a drama? The film's runtime in minutes, and the total revenue generated worldwide by the movie. Here's a list of the films that generated the most money in 2018. Black Panther generated $700 million worldwide, with Avengers and Incredible 2 close behind. Jurassic World, Aquaman, Deadpool 2, and The Grinch were also very successful. We see that many of the most successful films were action movies. Of the 7, the one that got the highest rating on imdb.com was Avengers Infinity War with an IMDb score of 8.5 out of 10. The rows in the data set, in this case the films, are called observational units. The columns, like IMDb score, rating, genre, etc., are called variables. A quantitative variable is one that takes on numeric values. For example, IMDb, score, runtime, and revenue are numeric variables, while a categorical variable is one whose outcomes are a set of categories rather than numbers. The movie's MPAA rating and genre are examples of categorical variables since they take on outcomes like G, PG, PG-13, R, or not rated in the case of the MPAA rating, or things like action, comedy, drama for the genre of the film. A bar graph is useful for displaying information about a single variable, a single categorical variable. In this bar graph, we look at the movie genres. The y-axis, labeled frequency, tells the number of movies of each genre in the dataset. We see that comedies were the most frequent type of film with over 40 comedies, followed by action movies with 40 and thrillers. There were fewer animation movies and family movies than the other types of movies. We can bring in information about a second categorical variable using a stacked bar graph. We now let color represent the MPAA rating of the movie. We see that for action movies, the light blue, representing a PG-13 rating, is most common. For animation films, the green is the most common color, telling us that PG ratings are most common for animation films. For biographies and comedies, we see that R ratings in purple are most common representing about half of each of those films. Bar graphs are good for displaying categorical data, but when we want to display a quantitative variable, we'll use either a histogram or a box plot. A histogram is like a bar graph, except that the x-axis now represents a range of numbers. For example, the tallest bar in the histogram tells us that there were more than 50 films with an IMDb score between 6 and 6.3. We see in this histogram that the most common scores given by IMDb users are between about a 6 and 7.5. The distribution of IMDb scores is roughly symmetric. In a box plot, the box represents the middle 50% of the data. In this case, 50% of the films scored between a 5.7 and a 7.1. The thick line in the middle of the box represents the median score, which was about 6.5. The lowest 25% of the films lie to the left of the box, while the highest rated 25% lie in the whisker to the right of the box. In this case, we see that a few films scored much lower than the rest. We refer to these as outliers and denote them using dots on the box plot. If we look back at the data set, we can see which of these films scored so poorly. Race 3, Slender Man, Holmes and Watson, and some others came out very poor in the ratings. Finally, we can use scatter plots to compare the relationship between two quantitative variables. In this scatter plot, we plot a film's IMDb score on the y-axis and its runtime in minutes on the x-axis. We see that there's a general upward trend in the graph indicating that overall longer movies tend to score higher than shorter ones on average. On the other hand, if we plot revenue against a film's IMDb score, we might be surprised to see that there does not appear to be any kind of relationship. The points seem to be scattered with no clear pattern, indicating that films with higher IMDb scores don't necessarily make any more money than films with lower IMDb scores. I find this somewhat surprising, but there does not appear to be a relationship between revenue and IMDb score. To recap, in this video, we've talked about how to distinguish between categorical and quantitative data, interpret results displayed in bar graphs, histograms, box plots, and scatter plots, and describe the center, shape, variability, and outliers in a distribution. In the next video, we will talk about how to use summary statistics to describe the center and amount of spread or variability in a data set.